Today we will learn about number system part 2. Okay, first we know that what is rational number. A number which is in the form of p by q, where p and q are integers and q is not equal to 0 is called rational number. Okay, then we see some example. 3 by 4, this is a rational number because it is in the form of p by q, and this is integer. 3 is integer and 4 is also integer, and q is not equal to 0. 4 is not equal to what? 0. So it is a rational number. Okay, next example, minus 3 by 7. This is also a rational number because minus 3 is a integers and 7 is also integer, and 7 is not equal to 0. Next example, 5 by minus 3. This is also a rational number because 5 is integers and minus 3 is also integer, and minus 3 is not equal to 0. So it is a rational number. Next example, 4. 4 is a rational number, as we know that it is a natural number also and integers also. Now what is this? Is a rational number? Yes, because it can be written as 4 by 1, and 4 by 1 is 4 is integer and 1 is also integer, and 1 is not equal to 0. So it is also a rational number. Okay, next we see that 0. Is 0 is a rational number or not? 0 is a rational number. Yes, it is a rational number because it can be written as 0 by 1 or 0 by 2 or 0 by 5, 0 by anything except to 0, because 0 by 0 is undefined term, so it cannot be defined, so it is not a rational number. Here we see that y, q is not equal to 0. Okay, q is not equal to 0. If it is q is equal to 0, then what happened? Okay, this is 4 by 0. Is this a rational number? It can be write as 0 by 4, and there is no any number that we multiply to 0 and we get 4. So it is what? Undefined. It is undefined. So any rational number which is in the form of p by q, where p and q are integers and q is not equal to 0, then it is possible. Okay, there are some fact about rational number. Next we see that what is the facts. And first fact is what? That every rational number do not have a unique representation. Every rational number do not have unique representation. Every rational number do not have unique representation, because 3 by 2, it can be also written as 6 by 4, also written as 9 by 6, also written as 12 by 8, and so on. So this is also a rational number, this is also a rational number. These are all are equal to the 3 by 2. So every rational number do not have unique representation. Okay, because these numbers are also called what? Equivalent rational number or fraction. This is a equivalent rational number or fraction. Okay, next we see that next fact is there are infinite rational number between two any given rational number. Q is a rational number, so there are infinite rational number between any two given rational number. How it is possible? Let's see this example. 3 and 4. Okay, there are infinite rational number between 3 and 4. How it is possible? 3 can be written as 3.0 or 3.00 or 3.000, 3.000, and also similarly 4 can also written as 4.0, 4.00, 4.000, 4.4 times 0, and so on. Okay, then in between 3 and 4 we can write as 3.1, 3.2, 3.3, 3.4, 3.5 as 3.9. After next it is 4, but we can write as 3.11, 3.12, 3.13, and so on. So we can say that there are infinite rational number between any two given rational number. Okay, we see some example. Find rational number. Find 4 rational number between 3 by 5 and 4 by 5. Okay, we have to find what? How many? 4 rational number. So first step is, how many rational number we have to find? 4. Then we take more than 4, more than 1 to 4. That is 5. So we have to multiply it by 3 by 5 into 5 by 5, which is 15 by 25, and 4 by 5 also multiplied with what? 5 by 5. Then it is what? 20 by 25. And now we can write between 15 and 20 4 rational number, that is 16 by 25, 17 by 25, 18 by 25, 19 by 25. These are the rational number between these two given rational number. Now next, when the denominator are not equal, the next our example is 5 by 6 and 7 by 9. Let's say 5 rational number. We have to write 5 rational number between 5 by 6 and 7 by 9. Then what is the first step? First, what we have to do, that first thing is we have to equate the denominator. Then how we equate? Then we take LCM of 9 and 6, that is 18. So we know that LCM of 6 and 9 is 18. So we have to multiply it by here 3 by 3 to make 18 of denominator of this fraction, that is 15 by 18, and 7 by 9 we have to multiply what? Which number? Then 2 by 2, because we have to get what? 18. So we have to multiply by 18. Now we have what? How many numbers we have to find? Then 5 rational number. Then we have to multiply it what? Which number? Then 6 by 6. We get what? 90 by 108, and here 56 by 108. Now we can easily write 5 rational number between these two numbers. Okay, then 56, then 57 by 108, 58 by 108, 59 by 108, 60 by 108, and 61 by 108. You can write as between 90 and 56 any number. It is not that only you write these numbers. You can also write as 71 by 108, 75 by 108, 79 by 108. Any numbers you can write, but it lies between 90 by 108 and 56 by 108. Okay, now we see the next example. Our next example is, if the number given that find 3 rational number between 3.3 and 4.6. then it is very easy that to find three rational number. Then what we have to do? First we have to change this number into fraction. 3.3, it can be written as 33 by 10, and 4.6, it can be written as 46 by 10. We can write between two numbers 33 and 46. That we have, it is not need to multiply it by what? 4. So because we can get three rational number between 33 by 10 and 46 by 10, so we need not to multiply these numbers. Okay, then we can write as 34 by 10, 35 by 10, 36 by 10, 37 by 10. If there is need, then you have to multiply it. Okay, otherwise you have not to multiply. Okay, now we see the next example. Okay, next example, write 5 rational number between 7 and 8. Then what we have to do? First thing, 7 we can write as 7 by 1, and we have to write 5 rational number between 7 and 8, so we can multiply it by 6 by 6. Okay, and it is 42 by 6, and 8 also can be written as 8 by 1, and we have to multiply it with number 6 by 6, that is 48 by 6. Now we can write between 5 rational number between 42 and 48, that is 43 by 6, 44 by 6, 45 by 6, 46 by 6, and 47 by 6. That is the 5 rational number. Next, our next example is true false. First example is every natural number is whole number. Is it true or false? First thing, every natural number is whole number. It is true or false? It is what? True, because natural number under in whole number. If it is under in whole number, because whole number what? Contain 0, 1, 2, 3, 4 to infinite, and natural number contain 1, 2, 3, 4 to infinite. Okay, 1, 2, 3 to infinite. So all natural numbers, here we can say that all natural numbers are whole numbers. Okay, so it is what? True. After this, every integer is a whole number. Now we see that what is integer. Integer is here. We know that integer made by negative, 0 and positive, and whole number contains only what? 0 to infinite. But these the numbers, negative numbers, are not contained in whole number. So it is what? It is false. Okay. Next example, every rational number is a whole number. Every rational number is a whole number. Then here rational number, and here integers, and this is the part of whole number. Then every rational number, in the rational number we contain what? Fraction and integers, and fraction does not come in what? Whole number. So it is what? False. Here we can say that what? 0 and negative. 0 and negative also not contained in whole number. So it is not true. It is also false. Our next question, what? Every whole number is natural number. Every whole number is natural number. Is it true or false? What? It is false. Why? Because whole number contains 0 to infinite, but natural number contain from 1 to infinite, and 0 is not included in natural number. So it is not true. It is also false. Okay, that is the now our second part is in. After this we can see that another concept, another topic of concept. Okay, thank you for attending the class.